Sathyabama Institute of Science and Technology.
Hello everyone, I'm R. Velvizhi, Assistant Professor, Department of CSE, Sathyabama Institute of Science and Technology. Here we'll go with the topic Greedy Algorithm in Design Analysis of Algorithm. We'll start with the introduction part. Greedy method is one of the best method in design technique. So greedy algorithm is an approach for solving a problem by selecting the best option available at the moment without worrying about the future what would the result being arrived. This algorithm may not be the best option for all the problems. It may produce wrong result in some cases. This algorithm never goes back to the reverse the decision made because this algorithm is a top-down approach. This greedy algorithm is also called as optimization problem. Why we call as optimization problem is mainly the problem will have maximum result or minimum result. Some problem will have the maximum result, some problem will have the minimum results. It fully based on the problem we define. Greedy algorithm solves problem by making the best choice at the particular moment. Many optimization problem can be used only through the greedy algorithm. Some of the greedy methods are greedy method, dynamic programming, branch and bound bounding. To explain greedy algorithm, we'll go with the traveling problem A to B. A is the source, B is the destination. To travel from A to B, here we are seeing mainly focusing on 4 solutions: S1, S2, S3, S4. S1 by walk, S2 by bus, S2 by train, S4 by flight. So, in a greedy problem, each and every problem will have a feasible solution. So, what is mean by feasible solution? Any solution that achieves a constraint to the given problem is called a feasible solution. Here to this problem, the constraint is the travelling time from source to destination is 12 hours. From S1, S2, S3, S4, from all the solution, we can achieve the constraint by 12 hours. So, all the solution S1, S2, S3, S4 are feasible solution. So, we are mainly the optimization problem will focus on the objective function. Here to this problem, the objective function is minimum cost. As we said before, either the problem should have maximum result or minimum result. So, to this problem, the objective function is the minimum cost. So, the optimal solution, to achieve optimal solution, any feasible solution which satisfies the objective function of a problem is called optimal solution. To this problem, the minimum cost is the optimal solution. So, through S2 travel by bus, we are achieving the optimal solution. So, to this greedy algorithm, mainly we are focusing on feasible solution, constraints and the optimal solution. So, here all the 4 solutions are the feasible solution, S2 is the optimal solution and constraint is the 12 hours. So, the greedy algorithms mainly have 2 properties. A greedy choice property. What is meant by greedy choice property? A globally optimal solution can be reached at by creating a local optimal solution. In other words, the optimal solution can be achieved by the greedy choices. The second property is the optimal substructure. The optimal solutions contain optimal subsolutions. In other words, each and every subproblems of a optimal solutions are optimal. So, for a problem, we will have a subproblems. Every subproblems for the problem will have a optimal solution. Now, to achieve the greedy algorithm, what are the steps to be followed? There are 3 steps to be followed: feasible, local optimal choice, unalterable. What is meant by feasible? Here we check whether it satisfies all the possible constraints or not. At least a problem will have one feasible solution to a problem. As we said, the constraint is each and every problem will have a one constraints to the solution. What is meant by local optimal choice? In this, the choice should be optimum, which is selected from the currently available. At the current moment, what is the solution is available, it's called as a local optimal solution. Unalterable, as we said, is a top-down approach. Once a decision is made, it is not altered by any solution. Here, we will see about the algorithm in the greedy algorithm. So, as greedy method followed by the stages. Each and every input, each and every stages will have a one input at a time. We are going to focus on whether the input is feasible solution or not. In this algorithm, we have a 2 elements as A and N. A is the array, N is the number of elements. Here we have a 5 elements, N number of elements as 5. A contains the N number of inputs. Initially in array, solution starts with the 0. Initially the solution starts with 0. Now we are starting with the input 1. From the input 1, now selecting the input 1 and removing from the array and placing in the variable x. Now the input from the variable x is checked whether the solution is feasible or not. As the feasible solutions are Boolean value, so it just checks whether solution is satisfied yes or no. If it satisfies the solution, it is added in the solution vector. If it is not satisfied, it is removed from the solution vector. So as likewise, we will check all the input from the array, and if it is satisfied, it places in the solution vector. Finally, the solution is returned. This is about the greedy algorithm. Now, finally, we will see with the example the coin change problem. We are given a set of coins for various denominations. Consider the given array, the set of coins of the basic denominations are 1, 2, 5, 10, 20, 50, 100, 500. Now the greedy approach. So we will solve the problem. The main solution for this problem to achieve the number 93. To achieve 93, we are going to pull out all the coins, the maximum highest coin from the array. Mainly we are going to focus on 5 elements. To achieve 93, first I am pulling out from the array number 50, because the highest number in the denominator to achieve 93 is 50. Now next is the 43 is left to achieve the result. Next, to achieve 43, next highest element is 20. I am pulling out the coin of denomination 20. Now 23 is left. To achieve 23, the next element again I am pulling out the number 20. Next the balance is 3 is achieved to be left. Next, to achieve 3, I am pulling out finally 2 and 1. Finally, the result is 0 is achieved. So, these are the optimal solutions. So, to achieve 93, we have the feasible solutions are 50, 20, 20, 2 and 1. Now, we will see the applications of the greedy algorithm. Selection start algorithm, knapsack algorithm, job scheduling problem, optimal storage on tabs, optimal merge patterns, single source shortest path problem, Huffman coding, minimum spanning tree, Prim's minimum spanning tree algorithm, Kruskal's minimum spanning tree algorithm. These are the applications to be used by the greedy algorithm to achieve the optimal solution. These are the optimization problems. This is about the greedy algorithm. Further sections we will see about all these algorithms. Thank you.